Hi there, you're right, it's Tommy Allen here, and today I just wanted to do a quick follow-up video of the previous thing I did of what it sounds like inside a massive dumbbell. So if you watched that previous one, this is what we had, okay? And I mentioned that the receiver size can make a difference to the auralization or the impulse response. Okay, so there's this equation here that determines the number of rays. So the more rays, the more accurate. Okay, but the bigger our receiver size, the less rays we need, which means less computational power. So what I'm going to do is I'm going to make the receiver size smaller, like so, boom, boom, boom. And we're going to run the calculations and see what happens. As you can see, as it gets smaller, the number of rays gets a lot bigger. So this is 70,000 in the minimum number of rays. And as we get bigger, the receiver, it gets smaller and less computationally power. So it should be 7 times quicker because there's about 7 times less rays. And what I've used to calculate the rays and the receiver size is this equation. It's from this book, Auralization of Acoustics, and I'll link it below, but here it is. And this basically says if we should get an audio accurate impulse response if we use this equation no matter what the receiver size. So if we can remember, this is like 100 meters long. We're actually using a 2 meter sized head, and then we're actually going to go to a massive 5 meter sized head. Okay, so rather than putting it in the game engine, I'm just going to pull up Ableton. I'm going to try and see what it sounds like and if it actually makes a bit of a difference. So here we go to Ableton, and I have set up a set of hybrid reverbs along the bottom here. So our first one, I'm going to put myself in the top again. So let's see what it sounds like. So I'm going to switch it on. We're going to hear the 5 meter. So we can hear those reflections that's going on. Let's see what the 4 meter sounds like. That actually sounds a bit more electronic with all the reflections coming in. I thought the smaller the head, the more kind of realistic it would sound. Let's see what the 3 meter sounds like. That sounds more... to me, that sounds a little less electronic, the way it's going through. And then the 2 meter size dumbbell, or the 2 meter size head. Yeah, they all actually sound the same. So using the equation, which, you know, is from a book, so I'm going to kind of believe if it's right, from the Institute of Acoustics, I think, or the American Association of Acoustics. So there shouldn't be any difference. By looking at the graph or the, impulse responses, they look kind of similar. This last echo comes in at different strengths. Here there isn't even one. At the end, we get a little dingy one. But yeah, there isn't that much difference. They all kind of sound a little electronic. So, yeah, and if we go all the way to the 2 meter. Yeah, so what we're getting, there isn't that much difference, so I can use that equation, it seems. Maybe I have to use a few more rays, I don't know. Maybe it's because of the weird geometry. If we remember, we actually have, this side is covered in curtains, so it absorbs a lot of the noise, and what we're going to get is all these beautiful extra reflections coming up and down the tube. But what I actually quite liked is is when I combined two of them. Or when I combine three of them. It sounds a little bit more realistic. And to me, kind of combining two of them, yeah, it sounds electronic there, as you can see. It actually kind of works. There's actually more reflections going on. It could be due to the weird geometry and the symmetry. But this is going to lead me down to like the next path is trying to get binaural. So what we're doing by having two, we kind of got two different impulse responses, very similar, mixing with each other. So if I actually channeled one of these to the left and this one to the right, and actually had them in two slightly different positions, we then actually might start getting a more true reverb. Because actually when I combine two or three of them, it actually sounds a lot less electronic. And that's kind of what you get in a real life situation. So that was just a good way to kind of experiment to see what I'm doing is right. I don't think this sounds perfect with just one of them. Like, it sounds like someone's generated a version of it through like a program. But I think if we get two, we can get more accurate. So it's actually kind of fun just to kind of show you like how this is working, what I'm doing. But we did use a massive space. I couldn't get down to 1 meter because there was so many rays. Like, it was insane. Like, it completely filled up my hard drive. So it was about, I think it's 200 gigabytes to figure it out. So it's not worth it. So this is trying to be, you know, efficient computationally, and then also, but also kind of accurate, because I don't want to be spending a day waiting for something to run. So that's just changing the receiver size, see what happens. I'm actually going to do maybe another experiment, or like, is it an experiment? Or like a test. If I don't bother using this lovely little equation and just changing the number of rays just willy-nilly and seeing how that affects. When I've done this, I kind of get quite ghostly reverbs because they're so sparse. It's like, bop, and then comes back in. It sounds quite cool, but it's not accurate. But that would be a nice thing, like to say, if we don't use the equation and use a massive number of rays, this might happen instead. So, yeah, I just wanted to go through that, explain it. Is my volume right? Yeah. And yeah, so that was just a little demonstration and just a little follow-up video to explain the number of rays and the receiver size. So I hope that helped. I hope that's a little explanation. And I'll see you guys in the next one. So I hope that was useful, and see you later.